Welcome. In a lot of situations, we will end up trying to find absolute extrema over intervals which are not closed. They might be open intervals, they might include only one endpoint, or they might be an infinite interval, say from 0 to infinity in a lot of applications. The method we used in section 13.2 applies only to continuous functions over finite closed intervals. If the original function is continuous at both endpoints, then we can find the extrema over that interval, including the endpoints. In a lot of applications, it turns out that the endpoints give the opposite extreme. So in the example of the box made from a piece of cardboard, we had a function defined over the interval from 0 to 2.5. The endpoints, 0 and 2.5, gave the minimum volume of 0. We were trying to find the maximum volume, so the endpoints didn't really matter at all. What if the original function is not continuous at the endpoint, or if one or both endpoints is infinite? Then this trick doesn't work. There are two ways in which we can handle this. If there is only one critical point in the open interval from A to B, then it turns out it's a relative maximum if and only if it's an absolute maximum. It's a relative minimum if and only if it's an absolute minimum. So we can use the second derivative test, for example, or the first derivative test, whichever is more convenient. Another possibility is to look at the limits of the two endpoints. If both limits are infinite, that means that as you go further out, you are getting larger and larger values. And in this case, it turns out there must be a minimum value, and it must be in that open interval. It must be a critical value. The opposite happens if the limits of the two ends are negative infinity. In that case, the maximum will be in the open interval, not at the ends. This technique works even if there is more than one critical point in that interval. In a lot of applications, both of these will apply. You can choose whichever is more convenient. We'll be doing 3 examples of this by using one or the other approach in the next 3 sessions.